Okay, so let's go through some practice problems, nomenclature problems that deal with those kind of first six rules that we talked about. All right, so with letter A here, we're going to first of all find the longest chain of carbons. Now that means I can number it like this, 1, 2, 3, 4, 5 if I went left to right, or 1, 2, 3, 4, 5, 6. So 6 is longer than 5. That's going to be my parent chain. So I'm just going to highlight it because the numbers might not be correct with in terms of substituents. And now I'm going to number this so that this carbon here, that substituent, gets the lowest value. 1, 2, 3, 4, 5, 6. And now I name that substituent. It's one carbon, so it's called a methyl group. And now I don't have any other substituents, so I'm just going to start forming my name. 3-methyl. Again, put a dash between the number and letter. And then 6 carbons is hexane. All right, let's take a look at B. Now, again, always start by finding the parent chain. So I could do 1, 2, 3, 4, 5, 6, 7. What would it be this way? 1, 2, 3, 4, 5, 6. Okay, so 7 is longer than 6. This is going to be my pathway. Now I need to number the chain correctly so that the substituent gets the lowest possible value. In this case, if I go left to right, the group here is on 4. If I go right to left, I get the same exact thing. So it doesn't matter in this case, and that's fine. You might see some situations like that. Doesn't matter if I went left to right or right to left. The substituent's on the same carbon. So I can pick either direction. Now I'll name this substituent. It's an ethyl group. And it's the only one, so I can start just putting my name together. So 4-ethyl, and then 7 carbons is the prefix hept, and the ending is A and E. So 4-ethyl heptane. All right, in the next one, start at our foundation, find the longest chain of carbons. So, I'll just kind of do something not right here first, like 1, 2, 3, 4. I mean, obviously there's something longer, so I'm not going to go that way. If I did this for 5, there's another possibility that's longer if I went here, 7, 8. So that's going to be my parent chain, those 8 carbons. And I got these two guys hanging off the side. Now I need to number this chain properly so that the substituent encountered first gets the lowest number. That means for this problem, I'm going to number left to right, because then that first substituent encountered is on 3. And I'm going to name my substituents. That's a methyl there, and that's a methyl there. So the way I'm going to put that into the name is, since I have 2 of the same, I'm going to put the prefix di in front of it. I don't have any other substituents, so now I can start naming. I have a methyl on 3 and a methyl on 4. So I'm going to separate 2 numbers with a comma, and a dash, and then dimethyl, and then the parent name, heptane. 7 carbons is the prefix hept. Now with D, again, I want to find my longest chain of carbons. So if I count this way, 1, 2, 3, 4, 5, 6, 7, 8. If I went the other way, 1, 2, 3, 4, 5, 6, 7, 8. What if I did this? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that blue pathway is the one that we're going to choose. So let me get rid of all this. And this is going to be my parent chain. Now let's see if I numbered it right, just by chance, because here is a substituent. So, and if I number it like the way that's shown there in blue, that group is on five. If I go this way, one, two, three, four, five, still gets the lowest number. So that group is on number five. Now in this case, three carbon group. I look at the table. Hopefully you have it memorized, or I memorized in the process of memorizing it. Three carbons is the prefix prop, and then I change the ending to YL. So that's a propyl group. So the name starts off 5-propyl, and then 9 carbons is the prefix none. So that's nonane, 5-propyl nonane. All right, let's get a little bit, getting a little bit more complex here. So if I were to number just going from left to right, one, two, three, four, that's only 5 carbons. If I were to maybe split down here, 5, 6, 7, that's a little bit longer. Um, let's see if I were to go one, two, three, and go here, that would be 4, 5, and 6. So that's not any better. It looks like that's going to be my parent chain, is 7 carbons. So let's make sure I have my numbering correct now. If I kind of go from left to right and start here, that numbering is like this. If I go the other way, the substituent encountered first gets a higher number. So that's not what I want to do. I don't want to do that red pathway. So here I want to keep this as is because that substituent encountered first is on the number 3. So I have a group on 3. That group has 3 carbons. As we said before, that's a propyl. And then the group on 4 is 1 carbon. That's a methyl. Now, in terms of the order of the name, methyl starts with M. That's higher in the alphabet than P. So doesn't matter that the number is higher. What we care about with substituents is that they're alphabetized in the name. So 4-methyl, 3-propyl, and then 7 carbons is heptane. All right, now with this final one, let's find the parent chain here. So I can do 1, 2, 3. I mean, I'm not going to go here because there's obviously something longer. If I just go left to right, 1, 2, 3, 4, 5, 6, 7. And what if I did this? 1, 2, 3, 4, 5, 6, 7. So I have two parent chains, or two chains that are equal in length. They're both the longest way I could do this. So what do I choose? I'm going to choose the pathway that gives me more substituents. If I choose the red pathway, I'm only going to have 1, 2 substituents. If I choose the black pathway, 1, 2, 3 substituents. So the rule as I go down my parent chain is going to have more substituents. That's the pathway I want to go through. So I'm not going to do that one. And it just so happens the way I've numbered it is the way that I want it to be, because the methyl groups on either side encounter number 3. So it doesn't matter if I go left to right or right to left. It's going to be exactly the same. So on 3, there's a methyl. On 5, there's a methyl, and on 4, there's a propyl group. Now, since methyl comes first in the alphabet, it's going to come first in the name. So there's 1 on 3, 1 on 5, and since I have two of the exact same substituent, I put the prefix di in front of it. Again, the numerical prefixes have no bearing on um, alphabetizing. It just tells the reader there's two of them. And so we're going to alphabetize based on M. And then 4 propyl. And since there's 7 carbons, the parent name is heptane. So I know that looks like a space. Let me fix that. Heptane, no spaces. All right, so hopefully, if you worked on these before this video, um, if you got them all right, great. If not, if you're still having questions, please come talk to me in office hours, or in lab, or just, come find me and let's, make sure that um, you have this nomenclature stuff down. And the next lectures, we're going to kind of go into some more advanced, kind of more exceptions that kind of pop up with these, with nomenclature.